I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, I'm a developer relations engineer at DataStax, and I'm here to talk to you about the idea that you just might be an AI engineer. The title of this talk is You Are an AI Engineer, and I'm hoping that if you find that idea somewhat resistant at the beginning of this talk, that by the end of this talk, you'll maybe consider that you might be, or you may have what it takes to be one in some due course. Okay, to actually get into it though, we have to speak about the term AI engineer. What is it? What does it mean? And this is important to establish because early in the field of AI engineering, I asked a number of folks, okay, are you an AI engineer? Do you think you have what it takes to maybe be one day? What does an AI engineer mean to you? And the answer that I got was often confused and also wrong. But the answer was, oh, I don't think I'm an AI engineer. And I said, why? Well, because I don't know linear algebra, because I don't know how to train a machine learning model, because I don't do data science. And it's interesting because a lot of the no answers that I got were ultimately no because I'm not a machine learning engineer. And this is very strange. There seems to be some type of conflation with data science, machine learning engineering, and artificial intelligence engineering. And I think it's very important to draw a big line in the sand and go like, wait. This is where data science ends. This is where machine learning ends. And this is where AI begins. And of course, it's a big Venn diagram. There's overlap. But let's see if we can maybe glean together what an AI engineer is in our time together. And to do that, I'd like to cite a really well-established resource by leaders in the industry, leaders that I absolutely look up to and have the privilege of frankly calling friends. I'm talking about the work of Sean Wang and Alessio. I don't know Alessio, but Sean is a dear friend. We go back a few years from the React web development days, which are still continuing. But Sean has since pivoted to AI, as I guess am doing or have done. In any case, Sean Wang, aka Swix, wrote an article called "The Rise of the AI Engineer" on the Latent Space website. Latent Space is his podcast and newsletter that is very, very, very popular, as you can see, and it's the premier resource for AI engineers. Okay, but what is an AI engineer? And this article that is well received and reviewed outlines that. So, what are we seeing? Well, we're seeing that we are observing a once in a generation shift right of applied AI. Okay, but what is the AI engineer? And this diagram really captures it well. It says this. This is the line between machine learning and AI engineering. So you at the very left, you have machine learning researchers, research scientists who do things like training and evaluating model outputs. Then or even evaluating the data itself. Then you have machine learning engineers and data scientists and research engineers who do inference. So they take trained models that the researchers give them and also refine the data. There's an API in the middle. And then behind the API, you have AI engineers, people who build maybe chains or use tools, etc. An AI engineer is fundamentally, according to this article anyway, somebody who uses AI for the solution of problems. Of course, if we consider engineering being the application of technology to solve problems, then an AI engineer is one who uses the technology that is AI to solve problems. Using AI to solve problems is fundamentally AI engineering. But again, don't take my word for it. This is what Andrej Karpathy says. Andrej Karpathy is the former director of engineering, I believe, or director of AI at OpenAI, previously the director of AI at Tesla, and is really, I'd say, the authority on AI and what makes AI engineering. And this is what he says. He says in numbers, there's probably going to be significantly more AI engineers than there are machine learning engineers and large language model engineers. One can be quite successful in this role without, what is it here? Without ever training anything. Without ever. So let me ask you again, right? Do you think you could be an AI engineer or not? And this time, you can't hide behind data science and machine learning. These are separate beasts. Okay, so what does AI engineering entail then? Well, we have access to artificially intelligent systems. We have things like ChatGPT and Claude. We have large language models. We also have tools that we can build ourselves as software engineers, tools that do things like retrieval or data augmentation, whatever it may be. And so, okay, we're sort of identifying work here that both machine learning, that AI engineers, and software engineers can do. Indeed, there is an overlap. So let's now talk about AI, because we've established that engineering is applying technology to solve problems. What is AI? Um, this is a good question. Now, historically, AI goes back very, very, very long. It goes back to the early 1900s, even, right? The first occurrences of AI is the occurrence of the term finite state automata, or FSA, which later became FSM, so finite state machines. Really, state machines were even conceptualized as a way of modeling the brain, because the brain moves through finite states, and AI finds its roots there. Ultimately, Andrei Markov would create the Markov chains as another basis of AI, and specifically natural language processing, where you would build a probabilistic chain of like the next likely word to come after a previous word. Markov chains, unfortunately, are limited in their context window to one. So using today's weather, for example, you can predict tomorrow's weather, but Markov chains don't have memory. This is actually called the Markov property. Without getting too much in the details, AI goes back way, 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 way back historically. And we can actually see that through the various types of AI. There are many different types of AI, and the AI of today may not be the AI of yesterday. So let's walk through, to really understand what AI is in AI engineering, let's walk through some of this. If we go back in time, really, really far previously, I was going to say far ahead, but far back, we find the earliest modality of AI was rule-based AI. This is your Pac-Man, right? When the Pac-Man eats the berries and the ghosts become blue. That's rule-based. When this happens, do that. Similarly, the ghosts chase Pac-Man when they're not blue and scared, and so on. All of this is just rules. You describe the rules and the computer does it. This is the multiplayer against AI in Mortal Kombat, where you're Sub-Zero and there's Scorpion and the CPU is like, get over here. And this is rule-based AI. Programmers knew the rules ahead of time. They codified them and wrote them down in programming code, and it created an artificially intelligent system. The system is intelligent because it can follow rules. Okay, that's AI of yesterday, or maybe yesteryear. AI of yesterday, so still AI and still useful, which rule-based also is predictive AI. And so it's very possible to create predictive systems using statistics, linear algebra, to create artificially intelligent systems. A great example of this is the Markov chain that we all use every single day without fail. Can you think of what I'm talking about? It is the autocorrect on your phone, which is often wrong. And it's often wrong because its context window is very small. It's actually one thing. So if you write the on your phone, then you get these suggestions left, middle, and right of the likely next word. And these are all just different probabilistic distributions of the next word. This is literally like a living, breathing, maybe not breathing, but a living Markov chain in your phone. It's predictive. It looks at historical context and then is optimized. The algorithm to predict the next word is optimized based on statistical probabilistic models. Okay? That's predictive AI. The AI of today, the one that's eating the world, the big hype train, is generative AI. And it's really just an implementation detail in the difference of the type of optimization in the algorithm. The algorithms bias towards something entirely different as opposed to predictive or probabilistic models. Okay, what do they bias towards? Well, they bias towards transformation. This is literally the title of the paper that preceded GPT-2, GPT-3, and all of what we see now. It's an architecture of machine learning model called the transformers architecture, which through a variety of hidden layers is optimized to transform input into a specific type of output such that it combines the dots in novel ways. It generates new ideas, new tokens that are still semantically and almost geospatially, vector space, related to each other. But the whole point is novelty. They generate novelty in a modality that can vary. So your text can become an image with something like stable diffusion, or sound, or video, or text, right? It's multimodal. So this generative novelty-based, novelty-biased AI is what's new and what's eating the world and what powers things like ChatGPT and Claude and Sora and Gemini, all of that. So we've got rule-based from yesteryear, predictive today and yesterday, and generative, which is very much tomorrow and also today. Okay, so that's sort of the types of AI. So can you be an AI engineer if you use really any of these to solve problems. And again, engineering is just solving problem through the application of technology. Sure, but where is it being used in the zeitgeist? And well, since the dominant type of AI in the zeitgeist is indeed generative AI, then one would say the application of generative AI to solve problems through the use of it as technology is AI engineering. That's the detailed answer. What if we be extremely reductionary and simplistic? We can say, and this is likely true, that if you're a TypeScript web engineer, which many of you are, and if you use something like Fetch, the Fetch API, to query the OpenAI GPT-4o API, get a response, use that response to solve a problem, that would make you an AI engineer. You're using AI to solve problems. You're using Gen AI to solve problems. That would make you an AI engineer. So let me ask you again: are you, or can you be, an AI engineer? Indeed, you can. What's interesting is there are a number of problems with AI engineering as well. For example, cost. Cost is the biggest one. It gets very expensive. We'll talk about those a little bit later, but for now, if we've established this is a field that we have potential in, how might we cultivate that potential? That's what I want to talk about. How can you either become an AI engineer or increase your skills as an AI engineer? And we'll use the remaining time to do that. Well, to do that, we have to identify some problems with Gen AI. What is probably the most prevalent problem with Gen AI today? Can you tell me? It's hallucinations, right? These machines, if we speak metaphorically, dream. They see things, they have visions, and sometimes they don't see the truth. They hallucinate. They see things that are not there. They invent facts, and they can be wrong. And sometimes they do it with a huge amount of confidence, which is really problematic. Okay, that's problem number one. Problem number two is usually they have knowledge cutoff dates. They don't have access to real-time information. By real-time, I mean like today. Like, should I wear a beachy shirt? Should I wear a sweater? Should I take an umbrella? Should I give this person a discount? Should I recommend that product based on their purchase history? It doesn't know. Typically, ChatGPT, especially when it was new, and GPT-3, you would say, based on my knowledge cutoff at so-and-so date, I can't answer that. Okay, so we have the problems of, number one, a lack of real-time information, and number two, hallucination. And we have a further problem of limited memory and context. It would be so cool if these things could just remember your entire lifespan and be your Jarvis. But unfortunately, at this point in time, I believe the maximum token length for GPT-4o, maybe 4,092 tokens. I don't know if this is true. I do know for Gemini, for example, another large language model, Google was advertising a 2 million token context window. Okay, what are tokens? Tokens, for the sake of our discussion, can be likened to some length related to English words. You could say one token is one word. This is not accurate, but it's close enough for the purpose of our discussion. So, okay, 2 million words in context, and then it starts forgetting, right? Do you have any idea how many? Like 2 million words is not that much. And yes, they'll say it's like a 2-hour movie, Google will, but still, that's very, very insignificant comparing like the length of human experience or customer experience. People have been using Facebook.com since 2006 or 2008 or something. And so that is 16 years of text and messages and likes and metadata that you cannot use reliably, right? So, okay, so we have hallucination, that is truthfulness. We have a lack of context, and we have a lack of real-time information. These are the big problems with the AI space. How might we solve them? Aha, this is AI engineering. So it's not only using AI to solve problems, it's solving problems that are presented with AI. These three, to name a few. So how might we solve some of them? I'd like to introduce you to one technique in AI engineering that is fairly common to mitigate these three problems. And that technique is called RAG, stands for Retrieval Augmented Generation. I will say this, AI engineering has advanced far enough now to where people are going, oh, RAG is so lame, it's no longer in vogue, but we're doing more complex things like modeling the multiverse. We'll talk about all of that, but I want to give you something practical that can also give you value. And there is absolutely no doubt that RAG is able to add value by overcoming these issues with AI. And so let's look at how we may implement some RAG. So I have a really simple example here. This is part of this talk is intended to be anyway part of a conference, JS Heroes, and they have a speaker schedule. So let's see if we can use Gen AI to predict or to talk to the next speaker. So if we go to the agenda, we have me, which is here, and we have Eva, which is here. Eva is an absolute legend, really, really tremendous speaker. I cannot wait for Eva's talk. But let's see if we can maybe create like Eva GPT. So retrieve information like real time that can't be hallucinated but can still be generative. Okay, so how would we go about doing that? How would we go about building a RAG, that is Retrieval Augmented Generation application, so that the AI doesn't hallucinate but gives us facts like Eva would? Eva would. Well, we do this using various tools. I just want to show you like with diagrams the mechanism, and then you do it how you want. Okay, I will, by the way, leak some API keys here, but by the time you abuse them, I probably will have revoked them. So anyway, how might we do this? Well, let's walk through what RAG is. It's retrieval, so you get some data, real-time data, ideally. Augmented, so you use it to augment the generated output. Retrieval augmented generation. So it's if you have a diagram in your mind, this is exactly it. You retrieve, you augment, you generate. So you get data from somewhere, you give it as context to a large language model, GPT-4o, Gemini, whatever it may be, and then it generates an answer. Retrieval augmented generation that isn't hallucinated, and that is truthful, and that pulls on the latest context because of retrieval. Okay, so how would we build something like this? Well, just to model the flow, I'll use a tool called Langflow. This is alpha software, but it really helps in the talk here. So to do that, come join me. What I have is a database. I'm using DataStax Astra because I work at DataStax, but you can use whatever you want. And we have this database, JS Heroes. In this database, I've got a collection called Eva GPT. And this is like Eva's posts from X, formerly Twitter. This is where they live, and I have some stuff here. 1,000 of them. Okay, so this is not going to be up to date. It's just here to make a point. How do we retrieve this and use it to augment the generated output? And to do that, I'll show you Langflow. So if I open my CLI and I do Langflow run, this is just going to bring up Langflow locally for me. And so it's starting. And at some point it will open, there we go. So it opened Langflow. And now I can create a new project and say vector store rag. And it's going to retrieve, augment, generate from a vector store. So this is why I'm using Langflow. It's a cool diagram of how it works. So you have a chat input to begin with. This is, the sender name is, let's say, me. So what happens to this input? Well, it sends the text as the input value to AstraDB Search, which is a vector search engine. And we'll talk about what vector is maybe in a bit. Then it also generates something called embeddings and also plugs those in to AstraDB Search. And this comes from OpenAI, as you can see. But you can use any embeddings model you want. Again, we don't need to understand vectors and embeddings. We will maybe, but it's beyond the purpose. So I'm using my OpenAI API key for this. And I'm speaking to AstraDB. The token is a global variable. It's called the Astra API key. And the endpoint is also, these are just environment variables, so I don't leak the answer. The collection name is Eva GPT. And I think we're good. Okay, let's go. And so once you get the results, the search results with our input value, then you break them down into chunks. And this is important for a variety of reasons, but really it's just to make sure that the information is in the right size to augment well. Okay, so we break it down into chunks. We then take those chunks and construct a prompt. And a prompt has a template, it has context, and it has the question. These come from the previous blocks, but the context we can change. Given the context above, which comes from our vector store, answer the question as best as possible. We can change this. We can say, you are Eva GPT, or you are Eva Ferreira. Why not? Ferreira. An expert conference speaker on web technologies. And we can say, here are some things you've said. And we say context. Using this, answer the question. Okay. That's it. And also reference yourself on X or Twitter. I don't know. We'll see how this goes. Okay, cool. And we'll just save that. Let's be sure to give our context and question. So again, the extracted chunks go to context, and the chat input goes to the question. Okay, cool. We're good. Finally, we connect the prompt to the large language model. Let's use GPT-4 Turbo. Should we? Yeah, why not? And we'll connect the text as the input here. The temperature is how creative we want this to be. So if we ramp this up, it's going to hallucinate still, maybe. So if we really want to reduce our chance for hallucinations and still be a bit creative, let's do 0.1. And we can tweak this as much as we want. Let's also enable stream mode so that it streams in the tokens, the answer. And finally, we have the output. The sender name is Eva GPT. That's it. So now if we play this, let's go to the playground and see what we have. I've revoked some tokens, so this may not work. Bear with me. So we'll say, tell me, what is Eva's talk about, actually? Eva's talk here is about, in this talk, we'll walk you through a few of my failed attempts for development. Okay. Let's just copy paste this into the prompt and see what we get. So about a few of your failed attempts at developing, and then we'll just say go through different accessibility assumptions. Okay, cool. That you wrongly believed. Okay, and we'll send this, and it'll probably fail because I'm maybe not authenticated somewhere. If this succeeds, I will be very surprised. Oh, wow, it totally succeeds. Okay, as Eva Ferreira, I've had my fair share of challenges and learned, this is so cool. And here are some issues that Eva may or may not talk about in her talk, but what you can see here is the chunks, the actual retrieved answers from the database, web accessibility in mind, a good read, and so on. 7 things every designer needs to know about accessibility. And so all of this comes from our database to augment this generated output and really give us an answer. Okay, let's actually ask about that. Tell me 7 things people need to know about accessibility. We'll send this and we'll see what Eva GPT says. And so again, it got this. I've often emphasized, and here you go. So this is 7 key points that every designer should consider straight from the database. So this is not, and we can actually maybe go look at that post. I think it's this one. Let's see where it got this, right? Okay, it's a link to Salesforce. Great. But in any case, accessibility is not a barrier to innovation. Don't use color as a visual means. It didn't, unfortunately, crawl that link. So I don't know if it will have this, but close enough. In any case, we're using retrieval from a vector store to augment the generated output. This is RAG, and this is a very common technique to deliver real-time information to large language models to then augment their output and give you data and answers without hallucinating and so on. Similarly, with Langflow, you can also just import stuff into your database. So here we have an insertion pipeline where we get data from like a file, we break it down into chunks, we map them to machine vector embeddings and insert them into an Astra database. We can also do this. In fact, instead of a file, we can get data from like the web, I think. Let's see, data. Let's go to data and yeah, a URL. So let's maybe get the latest real-time information for just the homepage. Let's go to n.wikipedia.org. Let's see what's happening. And we'll say Raymond Brownell is the featured article. So let's just get this. Let's get this and paste it into Langflow. So we'll do this, and we'll pass this record as an input to the chunker, and then we get embeddings and insert it. And let's just populate our environment variables, key, endpoint, collection name. Now let's call it Langflow. Let's go make that collection actually in Astra. Create collection Langflow. And we're going to use the embedding from OpenAI, choose a similarity metric. Okay, so we've created a database, and using Langflow here, we can just fill it and then ask it questions. So again, the Wikipedia main page has something about Raymond Brownell. So we'll ask a question about Raymond Brownell to get the real-time information as part of a demo. Everything looks good here. So I'm just going to hit play and insert the data. And it's inserting. AstraDB built successfully. The name is Langflow of the collection. So now let's go augment our pipeline, our RAG pipeline, to get it from Langflow instead. And let's ask tell me about Raymond Brownell. And let's see what chunks it gets. Here we go. Wikipedia, main source. Raymond Brownell was a significant figure in the Royal Australian Air Force, blah, blah, blah. Let's see if it fits. Was a senior officer in the Royal Australian Air Force. There you go. So RAG solves a number of problems. It solves the problems of memory. It solves the problems of hallucination. And it also provides support for real-time data. You could be like, literally, can you imagine the business use case, right? If you're Target, for example, and you want to know, should we discount umbrellas by how much? How can we personalize what we offer people? Well, you have Gen AI for that now. And using vector search in RAG, this is how you can get it. Let's wrap up by talking about some common problems here. I think cost is a big one because depending on your choice of model, this can get really expensive, up to, I think, $30 per million tokens. And again, a token is kind of like an English word. And you probably generate more than a million tokens, especially at scale. So there's work being done to mitigate cost and reduce cost. Some of that work is centered around caching. So you could, in theory, if two prompts are close enough, so two queries are close enough, then serve the cached result. Okay, but how do you determine how close they are? Actually using vector search. So you break them down into vectors. We'll talk about maybe what that means. And you check for similarity. Just like you're checking similarity between the prompt and the answer or the retrieved stuff, you check for similarity between prompt that is an input prompt and a cached prompt. And if they're similar enough, you just serve the response of the cached prompt. This is called semantic caching. And it's a mechanism that really helps reduce cost because at some point you don't generate new text from your large language model, you just serve stuff from some type of cache. Okay. The second problem is latency. Depending on the size of your generation can take time because these models are expensive to run and they do run these algorithms pretty rapidly. So latency can be a problem, especially because generation can take any amount of time that is arbitrary. A way to mitigate this, again, is with caching, but is through system prompt engineering, where you can literally say, hey, keep your responses somewhat terse and hope for the best. But in terms of latency, in addition to caching, that's the way. Prompt engineering is a thing. For this reason, you can literally say, don't speak so much, answer in as few words as possible, some permutation of that. And because the stream of message finishes earlier as its generation, latency goes down. I think, if I'm not mistaken, that is the best way to prevent long requests today, or long, actually network requests with AI engineering. But this is a space of innovation. And finally is just the data. And what I mean by that is sometimes you either don't have the data or you have too much data and the data is not good quality, etc. And this is something that's really important because large language models are being used today to generate what is called synthetic data. In case you don't have enough data to use for RAG, you can actually use GPT-4 or similar, some model, to generate data for you that you can then insert into your vector database, sort of flipping it, right? To then give it some basis to get real-time information to then use for augmentation and retrieval. So these are just a subset of the problems that AI engineers all over the world are solving. There's actually bigger problems. There are more problems. To reduce costs, some people are working on, actually a lot of people, myself included, are working on cases to, instead of just relying on semantic caching, you fine-tune, you train your own machine learning model based on a base foundation model. Mistral is 7B. Instruct is a very popular model that's actually made for this. It's made for, hey, here's a bunch of like prompts and responses, sort of like my semantic cache, but take these and fine-tune yourself on them so you have your own bespoke language model that is not so large anymore because it's more specialized. It doesn't need to contain the whole world of information. It just needs to contain your information that is relevant to you. So smaller language models through fine-tuning are another trend. Okay, let's wrap up and land this plane. We started with the question, or rather with the statement, you are an AI engineer. There may have been some resistance to it in the beginning. We delineated it from machine learning engineering, machine learning research, and data science, and we said everything after the API boundary is AI engineering. We defined it as the solution, the solving of problems with the application of technology, that is just engineering, and what technology? AI. And then we talked about practically what that means in the way of solving problems with AI, but also solving problems with AI. So let me finish by asking you again. Are you, or can you be, in the near future, an AI engineer? Thank you so much for listening so far, and I can't wait to hear your answers.